I'm Randal Schwartz. I'm your speaker for the next hour, so we'll see how well this goes. I have been a guest here at DragonCon for 15 out of the last 17 years. And for the typical times that I'm here, I've got like 4 panels or presentations to make. So I presume some of you have seen me here before. If you've seen me here before, raise your hand. If you know about Floss Weekly, the podcast I do, raise your hand. Thank you. Thank you. If you know about the Pearl books I've written, raise your hand. Yay. Thank you. Thank you. Pearl has been very, very good to me over the years. Today, I had pitched a talk that was more aggressive than I can actually deliver today to Scott, the coordinator for the EFF track, because I thought Google would be further along with Dart and Flutter than they actually got. So the talk I'm giving today is mostly the same as the talk I gave last year. And so if you saw the talk last year, you'll see a lot of the similar slides. I will do a demo, though, at the end, where I'm going to show editing a Flutter app on the iPhone emulator, the iPhone simulator. And then I'm going to press a magic button, and it's going to be the same thing on Chrome. And that's the new thing for today. That's what Google got working before today. And so that's going to be the cool thing for today. But what I want to talk about basically is why Flutter exists and what's cool about it. And again, I apologize for the quality of my voice. I somehow picked up laryngitis a couple days ago. If you can hear most of what I'm saying, I appreciate that. I'm going to point at some slides sometimes and just go, that's what I would have said. So, some of us are old enough to remember ancient operating systems that were provided by the vendor. Okay. And generally closed source, with a few exceptions. How many people are old enough to remember those? Yeah, we got a few here. All right. And then came the open source revolution. We had the BSDs, the Linux, and the others. And what's great about those is that customers could fix, extend, or modify the operating system, or even port it to new hardware, so they didn't have to be the hardware that the original vendors intended. And then they could share their code freely with others. But more importantly, there was this notion that you write once for Linux, and then you could run it on all sorts of hardware, all the way down to things like single board micro devices to supercomputers. And so Linux became sort of this universal interface for cross-platform compatibility. And that was really cool because it helped spread open source to everywhere, which was really important. But for the mobile side, the smartphone vendors have been like the early computer vendors. You had to have phone apps that were written with vendor-supplied tool chains that varied between platforms, and vendor-chosen languages that varied between platforms. For example, Java for the Android side, Objective-C for the iOS systems, things like that. And also APIs that were completely separate and changing from release to release, which means you had to figure out, am I writing for iOS 7 or iOS 8 or iOS 9? Am I writing for Android, whatever letter it was, those things, right? And also vendor-developed closed-sourced widgets that only existed on those phones. and gestures. So how would you go from page to page? All right, so the problem was then that if you released for iOS and Android, you had to have not just specialized skills, but also typically separate teams, because they didn't know the other side's thing. And I can tell you this personally because I work for ZipRecruiter as my primary client, and they have an entire separate iOS team and an entire separate Android team, because you had to have those people there. And the other thing is that it never quite looked the same on both platforms. So you use the native widgets, so the way it looked was horrible and different on each. So this is what's cool, is that starting a year and a half ago, Flutter came along, and the game has changed. The game has definitely changed. So Flutter is a mobile SDK app. It has the framework, the engine, the widgets, the tools, and it gives developers the way to make easy and productive way to build and deploy beautiful apps. And when I first wrote these slides, it was an alpha and then beta and then preview. It's production now. It's been in production since about 6 months ago. So there are people building apps every day in Flutter. There's something like on the order of a couple thousand apps in the iOS and Android stores that are currently using Flutter. And here's the thing between last year and this year. They're in a preview release so that you don't have to write a different code base for iOS and Android from what you write for a web app using the same technology or a desktop app. So for those of you that are familiar with Electron, being able to build using JavaScript a desktop app, you can now do the same thing in Flutter. This is amazing. This is a game changer. The Flutter people want Flutter to be the universal interface for everything, including Fuchsia, which we can't talk much about. I'm under an NDA, so I know more than you do, but that's all I can say, is that Fuchsia is huge. Fuchsia could be, is this recorded? This is recorded, right? So sadly, I can't actually say. If I could say, Fuchsia might be the replacement for Android, but I'm not actually going to say that. So if that's on the recording, I'm just making that up. I have no idea what I'm saying here. All right. I'm just saying that. And again, so some people are working on desktop apps like Electron. And Dart language is a very good modern language. It was based a lot on Java. If you're familiar with Java's, what do they call that? Anyway, the point is, you learn Dart once, you're developing for 5 platforms. You can use it server side like Node.js would be, NPM. You can develop for iOS, Android, desktop, web, and whatever this thing is called Fuchsia. All right. So what does it do? Beautiful UIs come to life. For developers, for mobile apps, and all these other platforms, you get all these places to deploy with the exact same code base. So you speed up the development cycle. I'm going to show you the hot reload in a few minutes. When I do the actual live demo, pray to the demo gods, right? So it reduces the cost and the complexity for app production across platforms. You're writing once, deploying 5 places. And for designers, rather than using the native widgets on iOS and Android, and even the web, you're able to deploy and have pixel perfect control over everything you see. And also you have productive prototyping, rapid changes without a long prototype cycle. So your developer can sit next to you and go, I want that to be blue instead of red. And you type one command and you hit reload and it just works. So Flutter uses Dart. Dart's a new language, unfortunately. You have to learn it, but it's a simple language to learn. It's got familiar constructs, classes, methods, variables, complex data structures, generics, type inference, imperative programming, loops and conditionals, functional programming, which is nice. You can say, I want to emit a series of events from this object, and I want to be able to track that as it happens. Very nice. And really, the nice thing about Flutter is you don't need experience in Objective-C or Kotlin or Java. You can just simply jump in. I've been writing mobile apps since discovering Flutter a year and a half ago, and I haven't needed to know any of that stuff. Yes, as I said, right, I'm doing mobile development now. So what we've seen, and I've seen this online, I spent a lot of time on the chat rooms about this, is that even people with very little programming experience seem to be relatively productive quickly. So what can we build with Flutter? It is optimized at the moment for 2D mobile apps, so not your 3D stuff, but they're actually talking about getting there soon. And it's also capable of brand first designs. In other words, I want to control, as the designer of this app for both iOS and Android, I want to control every pixel. I want to make sure it looks like my look for my app. And that's a step above, say, things like React Native, where you have to figure out how to make it work with the existing widgets on all the platforms. But you can mimic the stock platform for the look and feel. And you can access all the native things, everything native. And in fact, if it's not in this list that I'm about to give you, you can talk directly to Kotlin or to Java and actually talk to the native platform. So the camera, geolocation, network, storage, third-party SDKs, these are already provided. There's this thing that, for those of you familiar with Perl, with the CPAN, this thing called pub for Dart, and every day there are like another 20, 30 things being uploaded to that. So, Flutter is an open source project. It's on GitHub. Google did this from day one. They wanted to make sure that you were able to understand that even if Google abandoned this tomorrow, it's still going to be around. And that's a great thing. You know, it's all open source. The other thing is that their work is being done in GitHub. So you can submit issues there, and the team reads those and works on those and prioritizes those and comments on those. So this is not a quiet project. This is not something that Google's just doing kind of in their dark resources, because they could have. But they said, we're going to do this publicly. We're going to make this a public project. And so, very safe. And they do take community contributions. Google internally uses Flutter for business critical applications for iOS and Android. for their mobile sales tool, their store manager, and a growing number of internal projects. Google is also heavily committed to the Dart language because they're using this to replace GWT, which was their big thing about being able to build applications in Java on the server side and then convert that to JavaScript on the client side. And the two biggest applications that are making money for Google, AdSense and AdWords, were converted from GWT to Dart about 3 years ago. So we know that Google is committed not only to Flutter, but to the Dart language itself. And this is a huge thing. You know, this is how Google's making money right now. This is a big thing. So don't worry about this going away tomorrow. And there's already hundreds of apps. Many of you have heard of the musical Hamilton. The app for that was done in 90 days, from conception to deploy, using Flutter. And so everything you see there about being able to put your face on one of the Hamilton characters and things like that, that's all done with Flutter. That's all done with Flutter. It's amazing. So is it production ready? Yes. Okay, I didn't update this bullet, sorry. Flutter is 1.2 now, so I forgot to update this bullet. Dart 2.4 is already out. Sorry, I didn't get this slide fixed. Okay, sorry. And again, it's used extensively inside Google. This is not going away. I chat every day on Gitter with people from Google talking about how this is being used internally. And they're always talking to me about how crazy this is. You can submit a pull request if you want. And again, it's used by tons of companies already. This is just a small selection at the time that I did these slides last year. But pretty much, again, something like 2,000 companies are already using Flutter, already deploying apps in the iOS and Android stores about this. So what makes this different? Let's talk about what makes this different. In the classic applications, you had your native code on the left in green, and it would talk, and it would be written in whatever language your native app would be written in, like either Kotlin or Swift or Java or Objective-C. And it would talk to the native services in the lower right there in blue, the where you are, the camera, audio, things like that. And then it would talk to widgets that were provided by Apple or Google as OEM widgets. And that would then eventually write to the canvas and to events. So the first way to fix this, which was the strategy taken by React Native and Xamarin and a few others, is that there'd be some sort of JavaScript code and a bridge that would talk to the services, but they would then update in the upper right there the web view. So you'd have a web DOM that you had to keep updating. And the problem with that is, you know, DOM's been around for a while. We understand the DOM. But it's got a lot of overhead that has been inherited over the years. So that when JavaScript wanted to update it, it had to figure out, what do we really want to do? And then eventually it would talk to the canvas and the events and stuff. So that was sort of the first round. That's what React Native does. That's what Xamarin does and a few others. So the next update was that we made the bridge smarter. So we'd have the single JavaScript talk to both the OEM, talk to the bridge, which update the OEM widgets and things like that. A little bit better, but we're still going through a JavaScript to native things bridge. So here's what Flutter does different. So what Flutter has is that your code is completely compiled to native ARM code for the iOS and Android, and compiled to JavaScript for the web view and the desktop view. But there are channels now for the platform, and this is written in the native code. This is written in Kotlin and things like that. And the widgets. Am I hearing something here? Somebody got, was that next door? Okay, thank you, sorry. Don't mean to be interrupted. All right, and the widgets in Flutter are talking directly to a canvas. So they're doing a pixel by pixel resolution, and also being able to talk to events directly. So this speeds things up because there's not a JavaScript to native code rewriting, which is really cool. So what's interesting is that Flutter doesn't use the native OEM widgets. It doesn't use the native web view. We're not building up drop-down menus from the native platform. We're actually building we're actually writing pixel by pixel. So it's exactly identical. And again, this means there's no penalty crossing from inputs, app code, and rendering engines. Much nice. What's interesting is this project actually originated, and if you look at the copyright says, copyright the Google Chrome team. And it's because this started as a project. They're very noisy over there. I'm not noisy enough, apparently. All right. This project actually started from the Chrome team trying to figure out a faster way to build iOS and Android apps. And so if you look at the copyright, it all says the Chrome team. And so it uses their Skia, which is their rendering platform, as the basis for rendering pixel by pixel, and also how they lay out text and things like that. So this sort of came out of there. And that means the widgets are all written in Dart, which is really cool. And then there's a layer of C++ to talk to the native APIs. The other thing that makes this interesting is that at any point as you're editing Dart code, you can press show me the source code for this widget, and it's all in Dart. So you can go down and go, how does this actually work? And it was really cool because I could figure out that, oh, this particular parameter, although it says it has to be a widget, could actually be a column widget, and then I put a column in. And so you can see the source code to all this. Or you can copy and paste it and go, I want something that's like this, but slightly different. And it's all the source code. It's all code all the way down to the Skia layer. And at that point, you're screwed. But, it's really nice to be able to go all the way down. So it's inspectable, patchable, extensible. And then also the thing is that the cross-platform look is easily provided because you're doing the same pixels on both platforms. Well, now 6 platforms. You do it all. So again, at the lowest level, we have Skia and Dart and the text rendering engine. But everything on this page that's in green is all in Dart. So that means you can overlay the foundation, the animation, the painting, the gestures, the rendering, the widgets. And at the top level, you can have your application be written using Material, which is the new standard for cool websites. Or they even include something called Cupertino for if you want it to be exactly iOS looking. And it's funny, for like Cupertino, they did high-speed videos of how the iOS widgets worked and got the actual like delay and the rendering and the speed exactly right. So if you build with Cupertino widgets, nobody will know that you're building this with Flutter. This is amazing. And also for the material widgets, they did the same high-speed rendering, and they sent those back to the guys who were building the material widgets and said, here's the third order cubic that we came up with for how you're doing the delay. And they said, oh, that's simpler than what we were using. So they've actually adopted back. They've said, oh, that's our math. Okay. Because they used like Wolfram Alpha to analyze the pixels as they were drawing it across. Pretty amazing, actually. Does it have everything you need? Yes. Again, if you're mobile first, 2D rendering, excellent tech support, reactive style framework, rich set of widgets for Android and iOS. Here's the interesting thing. If you were building for Android, you also had to wait for the right widgets to show up for whatever release you were releasing for. With Flutter, they're actually shipping to releases that were before some of the material widgets shipped, which means you've got continual cross-platform support for material widgets. And Flutter is a first-class customer of material, which means that they will get implementations for material before anybody else does. They're a first-class customer. There's also APIs for tests. You can interop to JavaScript. You can interop to third-party applications. There's a wonderful headless test runner, so you can test this on Windows, Linux, Mac, all your platforms. You got command line tools, again, for creating, building, testing, compiling. I'm going to show you VS Code because that's my favorite, but really it works with things like Android Studio, with WebStorm, things like that. And as I mentioned earlier, for those of you familiar with the CPAN for Perl, there's this thing called Pub, and it lets anybody upload code and share it and have testing for it online. Really wonderful. So as far as editors, Google officially supports IntelliJ IDEA, Android Studio, and my favorite, VS Code, mostly because VS Code's free. VS Code does a lot of other really cool things. So if you haven't played VS Code before, and it's funny because I gotta say this is Microsoft. Microsoft is releasing open source code that supports other open source code. Could I have said this 10 years ago here? No. This is such a game changer that VS Code is so amazing. So, Visual Studio Code, by the way, if you don't understand. And again, Google supporting all those. So, fully integrated IDE, and it works for both the paid and the free editions of IntelliJ. And again, any editor that supports Dart, gotta say, if you like Vim, if if you like Atom, if you like Emacs, you're okay. It's not quite as good as looking at VS Code. Right. What's funny is the VS Code started as a third-party plugin, and Google was so happy with what the guy was doing on his own time, on his own dime, that they hired him. So he is now an official supportee of this plugin for VS Code. Unfortunately, if you're going to want to put it on iOS Play Store, the iOS Store, you have to have a Mac. That's just the way it is. And that's because of Apple's rules. But if you want to put it on the Android Studio, anything that runs Android Studio will work fine. You don't need to know how to invoke the compilers directly. The plugins know how to do that. So that's kind of nice, except for deployment. So again, the framework was inspired by React and React Native. And the interesting part about this is that rather than subclassing stuff, it's more designed to be compositing stuff. So you have a widget that has child widgets. Rather than saying, I've got a widget that is inherited from a raised button. Generally, you'll have a widget that just has a raised button. And it makes things a lot easier because you don't have to implement the entire interface that a raised button would implement. You just simply say, I have a raised button. And it does what it does. And what's interesting about that chart I showed you a few pages ago is you can use selected parts, or you could have an entirely different framework, or you could just cut and paste the code from raised button and make it do an entirely different thing. That's totally fine. What's nice about the way it's composited is that unlike the DOM, which is one of the things people are getting away from in this whole thing, which is why they thought this would be a much better deal. When you lay out a DOM, you've got to go all the way down, figure out everything about their constraints, then come all the way back up, and then sometimes come all the way down again because now you have a widget that needs a bigger space or whatever. But the people who designed this, the people who came from Chrome, said, let's figure out how to do this right now that we're starting from scratch. And so they said, we're going to do this in one pass. We're going to go down, passing all the constraints down, passing all the actual sizes back up, and we're done. And so the layout constraints are much cheaper in Flutter than they were in Chrome. There's also APIs for writing tests. Google uses that API to test the SDK on every commit. So every commit gets tested against a huge battery of layout things. So how does it run? So on Android, we take Android's NDK, compile it for C++. On iOS, we compile it with the LLVM. Dart code gets compiled in two different ways. When we finally deploy it, we do ahead of time compiled, which means we take a look at all the code that's in your application. And let's say you have a library that pulls in 100 functions, but you only call 3 of them. We throw away the rest of the code. It is compiled down to tree shaking and not doing anything else. However, if you're developing, you might change the code such that it will require one of those other 97 library, so we have to ship the whole thing to your device or to your simulator. So what's great is that we don't actually have a JVM at all. And again, OEM widgets are not used. All the widgets are pixel controlled, native code. So it is identical no matter what device you deploy to. This is huge because I've heard now in the last year and a half so many horror stories of people saying, well, I'm using React Native, but the way it looks over here on my iOS phone is not the same as it looks for Android. This gives us higher performance. This is all open source, so it means I can patch it, I can change it, I can see exactly what pixels it's trying to write, and I can fix that. And it's consistent on all phones, all OSs that are supported. So you don't have to have these weird, on Android, you have to have a lot of compatibility libraries as you go backwards in history. And again, as I said earlier, you can ship Material Design even before Material came out. That's how far back you can go, which is pretty amazing. So why Dart? It's a new language. Why choose a different language? Why not just choose JavaScript? Well, first off, I can say, thank God they didn't choose JavaScript. For anybody who's had to work with JavaScript, you understand exactly what I mean. How many people know the 7 ways to say false in JavaScript? Yeah, see, that's the problem, right? And the 5 ways to say true? Okay, right, exactly. Same hands. Same hands. There is exactly 1 true and 1 false in Dart. It's called TRUE and FALSE. Did I just do that right? Okay. All right, just making sure. So, the reason the Google team chose Dart, the Flutter team chose Dart, is that they could get the Dart team to create this JIT-based development style for hot reloads, which I'll demonstrate, presuming that demo gods are happy, to allow me to change things quickly. So what that means is we send the whole VM over to the device or the simulator, and we can change a few lines of code, and it only sends that incremental version over. That's amazing, because it completely is a game changer. Nobody else does this. But when we deploy, Apple doesn't let us have a JIT. So we have to have a completely compiled version of our application. But the nice thing about that is that we get to do a predictable launch. We also get to do tree shaking. So again, we have 100 subroutines in a library. If we only use 3, we only have to ship those 3. Way cool. Way cool. And Dart was migrated to have these 2 technologies by so the Flutter team influenced the Dart team. Flutter team being the Chrome team, essentially. And also that, given that it's in Dart, we have hundreds now, maybe thousands, of things in the pub, which, again, like I say, it's like the CPAN for Perl. Huge number of things, encryption, parsing CSV, stuff like that. So again, the Flutter team has influenced Dart team. They've also figured out how to optimize the VM for latency rather than throughput, so that your apps on your phone are very responsive. Really work well. And in the last few releases, they've influenced it to have strong mode, which is a sound type system, which means I can tell, more importantly, the compiler can tell that this variable will never have anything but a list of ints in it, a list of nums or a list of whatever in it. And that's very important. Let's talk about hot reload. Again, I'm going to show this to you in a few minutes. Demo gods be willing. Sub-second reload times. What this means is I can change like something from red to blue, and it will just say, okay, and show me. But more importantly, let's say I'm already midway down into my application. So I'm already like on the third screen or whatever. And then I want to say, oh, that should have been 10 pixels higher. I could just change that. And all the state it took to get there is remembered. This, again, game changer. Because nobody else can do this. This is amazing. Normally you'd have to go through the drill down through those 3 pages again, back down to that same page, as I'll show you. Quick iteration. And it works by having a cooperation between the compiler and the VM that's running on the simulator or the actual device to say, I'm only updating this code. So as long as this code doesn't look at a global variable, we'll be fine. And it just works. So you can add new classes, methods, and fields. You can't change the initializers for global variables or static field initializers or the main method of the app, but you typically are not changing that when you're building and rebuilding your app. So that's not really a problem. But even a hot restart is fast. So let's say you do change one of the things I just said you can't reload. The hot restart is only about a second and a half. So it's just fast. And unfortunately right now, the hot reload only works on the phone simulators and the phone devices. For the web, you have to actually do a full hot restart every time, which means you lose all your state. But that's still not bad. And they're working on making that work. It's like, my God, do these guys at Google have a job? I guess they do. Because they keep making it better all the time. They're just saying, that's why the web version and the desktop version are only in preview at the moment, because they want to get this working. They want to get this working for the web and the desktop version. What do you need for this? Jelly Bean 16, iOS 8, 64-bit devices. Is anybody going to have a non-64-bit device next week? I mean, really, everybody's going to upgrade. It works on live devices. I could plug my phone in right here, and you'd actually see it on my phone. Or iOS and Android emulators. I'll be showing this on an iOS emulator in a few moments. Google does test on a variety of phones, but they don't guarantee compatibility, especially if you have like a tablet, which is a little weird. But it's also possible to take a Flutter view into an existing iOS and Android device. They made that a lot clearer lately. Still more documentation coming on that. And then I crossed off not, because it is on the roadmap now. So desktop apps, web apps. They did a talk about 4 months ago, and the entire presentation was made on a desktop. And then at the end of the presentation they said, by the way, this was all done on Flutter on desktop. So it was like a keynote speech with slides, click forward, click back. It was really cool. And I actually have that software on my laptop right now, but couldn't get it to run the way I wanted to. And again, this is a little weird, but because Google is a publicly traded company, they could never announce a date because there's this restriction in the U.S. about forward-looking statements. So what's funny is, of course, I see this all the time in the chat. People say, well, when is Flutter on the web going to be ready? And I go, they can't tell you. They really can't tell you. But what they've told me, even being under an NDA, what they've told me is say, watch the burn down rate on the issues on GitHub, because that's all public. And they say, watch that burn down rate. That's the closest we can say to when it's going to be ready. But I love that because they're a publicly traded company, they can't tell us any schedules, which is really weird. Thank God for regulation. Okay, so what do you get? You get out-of-the-box access to platform-specific services. Interestingly, it's not intended as a lowest common denominator API, so you do get access to some pretty high-level stuff. Flutter Web can get most of what's in Dart HTML, which is what you would run if you were running it on your browser. Flutter on desktop can access most of Dart IO, which is what you would get if you were running it server side. So we do have access to a lot of stuff on both sides. Again, third party, pub, and Flutter's async message system can be used to create your integrations. You can also expose APIs, and you build abstractions that are best for the project. I've got till 3:30, right? Okay. So I want to make sure I have time for the demo. Thank you. So, widgets are everything. Widgets produce everything you're seeing on the screen. It's based on composition. Widgets are built from smaller widgets. And what's funny is that a lot of the widgets are actually composed of lower level widgets. Like a raised button comes from a material, which gives you the depth stuff, and a gesture detector, which means you have the rays that come out from it and stuff. And what's great is composition gives you the control over the visual interaction design and gives you the greatest amount of code reuse. And so they started with material, and they said, what really is this material widget built from? And they deliberately, in the Dart code, decompose those so that you could take any piece of that and go, I want to use that. And so it's greater mix and match. Greater mix and match. So Flutter supports calling into Java and Kotlin on Android. Supports calling into Objective-C and Swift on iOS. Great JS interop. Flutter Desktop still pushing along. The message passing style is async. So that means you can talk to the platform and then it can do its thing and then send something back to you, which is great. And you can often use the same API for both platforms, but you got to write plugins for that. So if you have a device that has multiple threads, multiple platforms, like my laptop here has 8 threads, you can do isolates, and that provides separate heaps in the VM, and they're implemented in parallel. You send and receive async messages to do that. Here's the great thing. No locks. No locks. For those of you used to using Java, you're like, what? Is that possible? Yeah, it's possible. No locks. So the way this happens in parallel is that you're basically sending and receiving messages. So each thread is presuming to running in their own space, and they don't have to worry about that. And what's nice is that you can also run on Android while the app is in background. And this bullet's wrong. Yes, iOS is also supported. So there's actually an example on the Flutter website of doing geofencing. So in other words, being able to have a notification when your phone gets to a certain location because it's running in the background. So yes, this is all great. Also, the code for widgets is all Dart. There's no separate syntax. And so the nice thing about that is that UIs are built with Dart. There's no language change for that. And Google finds this is more interesting because if you had a separate rigid markup language, you would have to figure out how to coordinate that with the Dart language. And some of you who have had experience with that, like from React Native, things like that, recognize the issues on that. It's also better because it means we can do hot reload easier once we know that we're only rebuilding these widgets. And it also means we can do code refactoring to build up complex objects. So let's say you keep coming up with this, 3-paned widget, and you could go, oh, I'm cutting and pasting the same code over and over again? No, let me just grab that and call it a new widget. And VS Code and the other two can do that just fine. It's also possible then to build a custom widget, custom language to build widgets at compile time. So, almost done, ready for the demo coming up here. So on GitHub, it's Flutter/Flutter. Open issue tracker. You don't like something there, or you want something to change, I definitely can tell you the Dart people or the Google people are watching the issues there. Absolutely watching the issues there. They want this project to be a success. I know as a Google developer expert that these guys want this to work. But if you have more questions, you can go to Stack Overflow. Lots of how-to questions are there. You can search for those in their searching. But if you ask a question there, it's typically answered within 12 hours, sometimes 20 minutes. So that's a great way to get your questions answered. There's a mailing list. I don't spend a lot of time on that, but there's a very active channel on Gitter, Flutter. And again, you'll often find Google people hanging out there answering questions. The thing is, it's all open source. With an extremely relaxed license. I think it's a BSD style license. There's occasionally a higher license if there's something they're using that had to be pulled in. So why Flutter? So we have the advantage of reactive views with no JavaScript bridge. Fast and smooth and predictable. We got code that compiles into AOT, to native ARM, or to JIT when we're developing. You have full control over all the widgets, all the layout. Beautiful customizable widgets, material based. Great developer tools with amazing hot reload, which I will show you in a minute. It's more performant, more compatibility, more fun. And although in the entire presentation I didn't say the fact that yes, you develop from iOS and Android from one code base, which is a huge advantage. You don't have to have two different teams. You can just simply code once and now work on 5 platforms, which I will show at least 2, presuming the demo gods work. Okay, it's revolutionary. Okay, and I won't show that part. Let me just do this. I'm going to quit this, quit that. I'm going to go to showing the same screen. I've got 5 minutes, I know. We'll be doing this. Hold on. Where is... Oh, that's going to be displays. Displays. Arrangement. Mirror displays. Quit this. Quit this. Okay, you're seeing the same thing I'm seeing. That's good. There is my iPhone demo. Okay, so now I'm going to start VS Code. I'm going to have to okay, no device. Why is it no device? Okay, iPhone 8 Plus Simulator. So what we're looking at here is some actual Flutter code. And I'm going to start up debugging. And I'm going to try to make this smaller. Well, I can either make the text bigger or I can make it so you can see the phone. So I don't know what I'm going to have to do here. Yeah, let me try. Let me try making this bigger. Okay. Except I still don't see the phone over here. Where is the phone? Gotta be able to see the phone. Oh, there's the phone. All right. Might have to switch back and forth a lot. Okay. So I'm actually launching the app. Now the app is pretty simple. Let me scroll this right. Scroll this left, maybe. How do I scroll this? Yeah, it's going to have to be that small. Otherwise, you're not going to see the phone. Okay, so what this is, well, let me make the phone smaller. No, that's not going to help. Make the phone smaller. Hello, phone. Can I make you smaller? Can I make you smaller? This worked last time I was here. I don't know why. There we go. Let's make the phone smaller. Oh, there we go. Because you don't need to read that text on there. It just says you got to push this button many times. Okay, so we're going to make this wider. And so here's the text of the actual app, which you really don't need to read, except that it says you have pushed this button this many times. But here's the thing. So up here at the top, you'll see it says colors blue. This is what's cool. I just said green. I hit save. Watch how long it takes. There. This is how fast you can be editing your Flutter code and see the result there. And it says Flutter demo homepage. Let's fix that to, we're done with this. Flutter demo homepage. Sorry, what? This is the Xcode emulator for Apple. So, I'm trying to find where it says Flutter demo homepage. Scroll, scroll, scroll. There it is. Well, let's do this. Let's get rid of this text widget. So I'm going to get rid of an entire widget and change this to pushed. Okay, so I'm changing two things at once. Done. So imagine working with your designer and just saying, you want this to be higher up or you want this to be over in the other area or whatever, right? And just have that. Okay, but I'm just running out of time. I want to do the web version first. So the web version is, I will show you. Thank you. I want to do the web version first, just to show you that I'm not kidding. I want to go to terminal. We're going to do on this version. Okay, I made a couple changes, right? You saw the couple changes. Flutter, run, -D Chrome. What? Oh, I missed the R. That would be comb. Right, that'd be something else. CHROME. But just to show you now, because this is new from that last year. Now it's building it for the web. This exact same code I just changed. Okay, so this is not a canned demo. It's launching, DC 2019. There. Same exact code running in the web. Running in the web. Awesome. Thank you, everybody. Thank you, everybody. Running in the web. Running in the web. All right. Quick questions. I guess we have time for one question, maybe. One question. Take the box. Yeah, some of the mic's not on.
That's my fault.
Got to push a button.
No, I gotta turn the volume up. Actually, it should be up.
Try it again.
What style of state handling does it use?
It'll handle anything except static initializer. So if you change a static initializer, you have to fix it. But otherwise, all the local variables everywhere are reloaded. It's amazing. Yeah. All right. Thanks, everybody. Enjoy the rest of the conference.